So let's go back to that example I was talking about some mass experiencing a gravitational pull by some other mass, right? And this is true regardless of what the size of the masses are, but usually the bigger one pulls more. So what does this look like? So let's just assume we have a large mass, m, at the origin, right? So we just make the origin the center of this large mass, okay? And then m is some smaller mass. Then, well, what is the force that big M exerts on little m? Right, so big M is the mass of the large mass. Little m is the mass of the other guy. I mean, they could actually be the same mass too. That's fine. But let's say the force exerted on m, little m, by big M is, well, this is given by the inverse square law, right? So f of x, y, z, right? And what we're going to do here is actually make r, the vector, equal to x, y, z, just to make kind of this notation easier. X, y, z with the vector. Right? So this satisfies the inverse square law, which is negative m, little m, the gravitational constant. And this is so the inverse square law says it looks like this. Right? And then times the direction. The direction is always going to be r over magnitude r. Right? Okay. So r here, this is the position vector of little m. Right? Okay. So you could also, of course, write this as, negative mmg over magnitude of r cubed times r. But this is how you see the inverse square law coming in. Okay? And yeah. So let's actually talk about another thing too, just to give another example of a vector field. So let's say we have a particle with electric charge q and instantaneous velocity v, okay? And let's say it's moving in the presence of an electric field and a magnetic field. So moving in the presence CE of an electric field. Let's call that guy E, and a magnetic field B. Okay? Then the particle experiences a force given by, well, we have the charge times the electric vector field, right, the electric field, right? But we also have the charge times the velocity across the magnetic field. And I'm pretty sure that is the right order. Excellent, it is. All right, so this is the force that experiences. So these are just two examples, two quick examples from physics that show you where these kinds of things can show up, right? And there's many other vector fields that can show up. And for example, over here on the electricity and magnetism side, it shows up in, now I've gone and forgot the name of it. The circuit rules. But so they're very useful. You're going to have to put a little comment over me saying how bad I am, that I can't remember the name of this guy right now. Oh well. Anyway, so here's just some examples, and enjoy.